gonna be 10, 54, 16.
Alright, we're flowing. It's going from the inside to the outside. All right, let's
We're getting a response from one cell, right? A piece of us. Switch over to Emily.
hold on for it a little longer.
There's a laptop which runs experiments. There's a microscope. There's the actual R Health itself, and we also have a glove box. Potential laser light. So the R Health is driven by a small laser inside the system here. As you can see, it's entirely closed by a black box, which won't
A project that we're doing for ISRU in situ resource utilization. We're doing a pneumatic regolith feed system for an oxygen production reactor unit.
I have a team with us today that we will be looking at some slosh dynamics experiments in a low gravity environment. The project that we have here today, experiment, is to make a series of measurements on how liquids behave in low gravity as the aircraft is in free fall. The purpose of our experiment is to try to simulate some of the conditions and environments that actual rocket vehicles would experience when they're traveling, say, from a from a low Earth orbit to a geosynchronous orbit, or as they undergo orbital maneuvers.
This is the regenerative filtration system experimental rig, essentially testing some filter concepts for space missions. The hardware, as you can see, is basically a main frame plus a flow duct up here. This is where our experiment actually takes place. This is where our measurements are occurring.
And what we're doing is we're taking a lunar soil simulant that's a makeup of several different minerals, and we put it in the hopper here, and we use the motor and the tapper as a metering device to meter it down through these triboelectric tubes. As the soil rubs against the aluminum, it gathers a small charge, like rubbing your feet on the carpet. Then it falls through two high voltage electric plates, creates a uniform electric field between them. The different minerals will charge differently against the aluminum, thus we're able to separate the more iron, more conductive minerals from the less conductive glasses and other things like that.
The model system we're flying is a burn spore called Ceratopterus, and it's a gravity responsive system, so we're able to measure calcium signaling associated with cell development.
So magnetic flux pending, just for a brief background, is an interaction between superconductors and magnets, where the magnet, once the superconductor is cold, will stay pinned in place at 6 degrees of freedom. So the idea is that if you cool down a superconductor below its critical temperature, in this case it's 88 Kelvin, you can get a magnet, once it's in its position, to stay there. So we're actually looking at putting a superconductor ultimately on one module of a spacecraft, and then magnet configuration on another module of a spacecraft, and using this interaction to get some kind of docking or assembly in space.
All right, well, we're from Johnson Space Center here in Houston, Texas, and we work in a realm called ISRU. It stands for In Situ Resource Utilization. Basically looking for ways to live off the land and resources that we find either on the moon or Mars or whatever destination we happen to be. In this case, this experiment is designed for a potentially lunar application. We'll be flying in the lunar G parabolas, and it's designed to investigate a mixing method for a process that we use called hydrogen reduction, which is a process that's designed to extract oxygen from lunar regolith.
We're flying 2 experiments in this one box. The first one is a cryo cooler. The second one is a heat pipe. I'll go through the cryo cooler first. It actually flew with this particular box in April of this year with a student team. We've made one modification to it, and that is to add permanent magnets near the cryo cooler itself. The heat pipe, X pipe, supports the core of the Vasimir rocket, and this will cool down the hot components.
We strip the servo motor and attach the flywheel and use it as a reaction wheel to change the orientation of our satellite.
Essentially, we have a 2-tank configuration here. What would typically be on a Centaur stage would be a LOX tank and a liquid hydrogen tank. So we have 2 LOX tanks as well. We actually measure our acceleration rate using 3-axis wireless accelerometers mounted in this bulkhead right here. On this end, you actually have a port window. You can actually have we're gonna have a camera right there, which is right here. A little Terminator eye looking camera. And that will actually be looking straight down into the fluid level as we're doing these tests. The whole idea is to actually develop something, not only a replicant or a scale model of the Centaur stage, but build something that we can spin with this rig.
Pretty much what we have going on here is this is a double contained particle system with gas recirculating inside the system. We're using a flow meter that will measure the flow rate as well as the pressure and temperature so we can get the density. We'll be able to change the flow rate using this this switch. The gas will come through and penetrate the particle bed. There's a window right here with a beveled edge, so that we have half of the gas jet flowing into the particles and the other gas jet flowing in front. This way we can acquire data on the inside of the crater. Titulates to illuminate the surface of the bed so that the camera can acquire a sharp contrast between the top surface and the side wall.
So the idea is pretty much we'll load up this suitcase. We have these mounting rails which will bolt them onto the aircraft floor, so this thing will stay closed during the parabolas and keep everything contained. The modules themselves all have Velcro on the bottom, which will
stick them to these mounting plates, which will also be bolted to the floor. So we'll have a couple stowage plates around the area where we've been assigned, so that we can take one up during a parabola, pop it open, and then stick it onto the Velcro, deploy another one on the next parabola. As soon as we hit the parabola, it has a 3-second timer.